Mr. Kevin, you are wrong. So, good afternoon, everybody. Welcome to Advanced Refrigeration Podcast. You're here with your host, Brett Wetzel and Kevin Compass. How are you doing? You were going to MIA this week.
Too bad. It's Saturday. I was kind of on a random weird project that I quoted to do. I was doing startup for a manufacturer support, and I was at another union hall in Detroit doing a startup on a training unit. It's pretty cool. It's interesting, different, like way less stress because there's no food coming. There's no food to lose. It actually wasn't a bad week.
Yeah. You were out. Where was that? It was out in Michigan all week.
Yeah, I was in Detroit, which is like a 4-hour ride for me, so it's not like incredibly bad. It's another 30 minutes for me to get home from some places in Illinois that I go to. Yeah, it wasn't that bad. The ride home absolutely sucked because the highway was closed, and so I had to back road it home. But no, it was an interesting week. Like I got to see some cool stuff on this trainer. Like it was a manufacturer that I have yet to start up a CO2 rack for, or a rack in general for, and I was thoroughly impressed. So it was a ARNeg Canada, because there's a difference.
ARNeg USA and ARNeg Canada, they're two different things, I guess.
Two different things.
Oh.
It's owned by the same company as a mothership, but two different things. ARNeg Canada and ARNeg US are not the same. So ARNeg Canada made this rack, and for the UA, for this Detroit local, and it's pretty cool. It had some pretty stable loads once we got it trimmed out. We ended up changing the design at the union hall, so we ended up rewiring a bunch of it, half the evaporators, to change the design to make this thing a little bit more functional, and so we can get a little bit more out of it as we played with it. And it actually worked out pretty well. So probably one of the nicest installed racks I've ever seen. Wow. They've been working on it for a while, so they had fitters in there just TIG welding everything. And then honestly, probably one of the nicest laid out racks I've worked on so far for CO2.
Very cool. No, I taught this week. I taught 2 days this week. And excuse me. Then after that, basically we've just been doing curriculum and building, and Monday was Memorial Day, obviously. So I don't know if did you work Monday?
No, I was off-ish.
Okay. But yeah, so it was really funny. I was doing a basic cascade class, but I threw a lot of basic refrigeration in there. And this one kid just throughout the whole thing, like I would bring up things, he's like, kaboom, throughout the whole thing. He's like, kaboom. And then later, like because I only trained for 2 days this week since they had to run down to do some other training elsewhere. I'm going to be training them, I think, in another 2 weeks with the hands-on portion. But he was sending his friends a picture of him in SWAT gear, like SWAT bomb gear. It's like when I'm walking up to a CO2 rack, I was like, I didn't scare you at all. I don't know. He the first time ever going to be working on CO2, so he's just scared. But I told him, I said, it's one of the easier ones. Just got to be more cautious. I kept throwing a filter dryer at everyone because they'd answer questions, and I was like, what's one of the first things you do? And they're like, close off the valve. And I throw it at them. It was like, gauge up, gauge up, gauge up. Yeah. It's not as hard as TC, but
it's boring CO2.
Unless everything's flooding back.
That was fucking rough. I still think those check valves around those expansion valves are the dumbest thing I've ever seen, and I've seen a lot of stupid things.
It makes sense though. Like it
didn't. It was it'll push it open the other way.
But how? Maybe, possibly.
It'll 100% push it open the other way. But like the benefits, the benefits didn't outweigh the disaster it caused.
Yeah, but if they would have checked him out first, what
are you gonna do? You seen how hard it was to see where the arrows were on some of those? You looked at one for 20 minutes trying to figure out what direction it was actually in.
Dimples.
Yeah, but you couldn't see them, half of them.
I hate you.
I don't know who piped those condensate lines, but it was awful.
Anyway, so I guess we're going to talk about your ARNeg rack that you were getting to play with. So I'm going to pick up the P&ID and I'll just mouse around. And you just tell me where you want to go, how do you want to explain this, and I guess we'll go from there.
Yeah, let's do it.
Oh, gotta get rid of that. Oh, can't show that. How'd that get up there? Nope, not that way. Yeah, that way works. Okay. So, go ahead, start, man. What do you want me to do?
This is more or less a basic booster rack, okay, with some added things, okay? So we got our medium temp compressors down below. We got some Copeland MTSs. So we got standard Copeland TC compressors on here. We're going up to our discharge, which I'm trying to follow, but my
red.
I didn't make my screen bigger. I can't see. So you got your standard discharge. It goes to your oil separator, comes out of your oil separator. And this is what everybody's been missing. And I don't know why. This is the only manufacturer I've ever seen do this. We have split.
Whoa.
Any split. We have 25, 50, and full.
What the hell?
It's magic. It's unicorn.
It is magic.
It worked damn good.
It's Canadian, though. That's good. That's what I'm saying. They've been doing it for years up there. We're the slow behind, I guess.
This is like a game changer with this. And to be honest, I don't know why more people aren't doing it.
So let's talk about this for a sec, because we had theories on how we would do pump out or whatever.
So they are not doing pump out.
Oh.
So they are leaving the gas in the coil, and there's check valves on the drop legs. And according to them, the amount of gas that is left in the coil is not a problem.
Okay.
If you split properly, they're not having an issue. I think it may need split or a pump out, but on this racket, it's definitely not going to need it. It's too small and it's getting blown down anyway when they're done.
Yeah. So let me so right now, this is all the ins for the gas cooler, right? So
yep.
25%, 25%, and 50%. So all together, you run 100%. Okay. Perfect.
Yep.
Now I gotta finagle the P&ID.
Yeah, it gets weird as it goes to the condenser.
Yeah, that's what I'm trying to go to now. Oh, right there. Got it. What's that? There's your 25 split, 25 split, and there's your 50 split. So it goes out that. Oh, okay. So this is they're splitting. So they're splitting 25, 25, and then leaving the 50.
Yeah, leaving the 50, and then there's 25, 25.
Oh yeah, okay. Because here's your 25 and 25 check valves right here.
Yep.
And then you have another check valve over yonder. So it
doesn't show up. There's a check valve on the 50% split.
No, there is right here. It shows it right here, right before it tees in. So everything combines into a massive drop leg out, and then goes to DC-4. So where the hell's that?
So that comes into a heat exchanger. So if you scroll down.
Oh, right here.
Yep. So we're using kind of like the LMP style subcooler / reheat. So this was originally designed to be a subcooler. So they're using, when the drop leg, their original set point, I think it was like 95 degrees. When the drop leg's above 90 to 95 degrees, then they're going to energize the ball valve between the two, and it's going to shut. So it's going to force gas through the heat exchanger, and then it's going to pick up cooling from the medium temp suction. But so we had such a small system, and we had some superheat issues trying to get it to, because it didn't have much. It's a trainer, so it's a stable load, but it didn't have enough to get it to where I needed to lower the superheat enough to make it run properly, because it was so close. The loads are literally on the rack, so there's no piping to pick up any superheat. So we ended up using this to get the medium temp suction to a proper temperature.
So you could basically you probably turn down the superheat a little bit on the evaporators, and then
Yep.
use this to. Looking at this now, because I didn't realize you had one of these. This is probably the reason why you were.
No, so we didn't turn this on until after I took those videos.
Oh,
So this was not in play yet.
oh, because this is going to change the whole game if you're dropping
Correct.
that leg down. Because if you
No.
cool it down further, it's going to make that quality liquid thingy that we're going to talk about in a little bit here do what it's going to do, right?
Correct. No, this was actually off. It was in bypass. So we had not tested this at that point. So the bypass was open and the ball valve going into the heat exchanger of Metropolis was closed. So it was not flowing through the heat exchanger at all.
This ball valve right here.
Yep. So it was it was closed going in there. It was bypassing.
Oh, so you have a motorized valve here, but then you also have the solenoid here. I didn't realize that there was another.
It's not a solenoid, it's a motor, it's a motorized ball valve in the middle.
Is it really?
Yeah.
Oh, it's just a 24-volt where it just opens up. Okay.
Yep.
Oh, I didn't. Okay, I thought okay. It was a head too small. So you got
Yep.
M and M. So motorized ball valve.
So
Okay.
yeah, the bypass ball valve was off and the bottom ball valve was closed going in there. So when we took these videos, it actually wasn't in play, but it worked phenomenal once it was in play.
Okay. Probably even better.
The side glass is cleared like 99%.
That's freaking crazy.
Scrolling out of this, so leaving this, you got your drop leg are all tied together now, and now you're gonna go back. It goes back towards the rack side. So
Right here.
yep. So it comes in here, and on this rack they have a primary and a backup GCV.
Yes. Cool. Oh, okay.
So
I'm
there's
like-
4 GCVs. So
No, I'm like HPV. I'm like, who's the fuck is GCV? Okay,
so
but that's just the
before
valve.
that, there is coming from the gas cooler is a ball valve and a strainer. Okay, there's a Castell strainer on there. So then you have 2 GCVs with ball valves on both sides of them and bleed down taps. Perfect, works awesome. Okay, then leaving that is you go through. You got your sorry, we'll go back the other way real quick. So there's a sight glass right where it says schedule 40 or right there. So there's a sight glass right there. Okay. And then to the right of it, you have where the PG is, there's another sight glass.
Oh, so you can see how much liquid there was, and then how much liquid, like how much it's flashing off after.
Correct.
Ooh.
And then leaving there.
Oh, yeah, right here.
Yep.
There's your sight glass there, and they don't have it on. It must be on the other part. Real quick, let me just look. Nope, not on there. They just missed it on the print. Right
Yeah,
there.
they missed it on the print, but it's right
there.
It's before the T.
Oh, there's your strainer.
Yep, there's the Castell strainer. That's actually moved back though. Like so, it's right there, and there's a ball valve in the inlet to it.
Okay, fair enough. All right.
As you come down, now you have T. They put 2 T2 from the iPro over here. They were just using it to monitor. So T2 is there, and then there's a secondary pressure transducer for the receiver pressure.
Hold on, quick question then. So does that mean that T1 is actually back on this guy over here?
T1 is on the outlet leaving the heat exchanger.
So predominantly they're going to use T1, right?
Yep. T2 it was just there for a monitoring point. It wasn't.
No, understood. But if you'd move it, then it would move off because you're going to remove, like once this is in play, right? You're going to remove a little bit of heat first, right?
Yep.
Yeah, from the outlet of the gas cooler. Okay, yeah. Okay. Go ahead, continue.
Okay, so as you go down, you hit the receiver. Flash tank, standard flash tank setup. So you go down in the receiver. Okay. This is a little weird because that where you got 47 flowing into the receiver, there is what they call a flash tank destabilization valve. Now, because this was a trainer, they were taking the discharge of a low temp, boosting the pressure up with a Danfoss inlet pressure regulating valve, and they were taking that and dumping it into the flash tank to build heat to make it seem like the flash tank was destabilized. So basically, when you throw an input on the E3, it would inject hot gas in there and show guys what happens when the flash tank's all destabilized and the rack can't keep up.
Oh, so just showing you that it's going to eat shit on the flash tank, and then your graph was going to go all over the place.
Yeah, it go all over the place, and like it destabilized it. It worked fairly okay. It was Harry setting it up. Then you had 3 level sensors on there. So
what they use on there for ARNeg?
just the Crewan INTs.
Yeah, I didn't know if they use Kirwan or Tech Lab.
Yep. So you had the Kirwan INTs, and then coming out of you have the flash gas bypass valve with the dip tube up. So that is actually how they're supposed to be. See that dip tube in there?
Yeah.
How it's pointed up. That one's going up to your flash gas line. Now, this is where it gets a little, or no, that's going to the heat exchanger for the
Yes. There.
backup unit. And then if you follow it all the way around, this is where it got pretty cool. So go down.
Right
It's
there.
going to your flash gas bypass valve. Okay. And then in parallel with this, they have a Danfoss constant pressure valve. It worked kick ass.
So this worked. Did it work better than the BGV? Really?
Yes.
No shit.
It was like within 3 to 5 pounds.
Get the hell out.
So this is genius. They have a constant pressure valve, and they have the FGB there also. So that the FGB is controlling your flash tank pressure, but they also have a Danfoss. This one, we were messing with it. We put it in play, raised the flash tank set point up, and then we put it in play, and then had it, and it maintained perfect. So
how big was this valve? Because a lot of times when they don't do these, they're the same size as this guy.
It was the same size, same pipe size at least. I'm not sure I haven't actually looked at the Danfoss nomenclature to see what cartridge is in it, but I'm telling you right now, like I had the rack like 75% loaded, and it was maintaining the flash tank beautiful in transcritical. I honestly think this is a more viable solution than running an FGB. You're going to need some tweaks here and there because those valves do hunt a little bit, because I've seen them on the Carnot racks, but I'm saying right now the manual valve is killer. Why overcomplicate it?
And then you could put a solenoid. You'd have to put
The valve did have a solenoid on it, so you could kill it.
Was it? Did you have to? Was the solenoid have to be energized for it to open?
So the solenoid has to be energized for it to
close.
Yeah,
so you'd like to have it the opposite way, I think, because then you want this thing to close. Otherwise, you'd have to.
It's those Danfoss ammonia style valves. So I'm sure you could do it either way you want. You can configure these valves however you want.
Oh, it's the industrial style, so you can change you can change the stem at the top, so you can make it vice versa.
Yeah, so you can make those industrial style valves do whatever you want. You just gotta. It's like a Flowcon valve. Like you can build however you change the valve around is how it works. But dude, it works so good. I honestly think that this is a more viable option than running a electronic valve.
No shit.
To run one electronic valve on the high pressure side, and I think the flash gas on a manual valve is going to be such a better solution, or at least a backup for that. So then leaving there, it ties into what'd you do?
No, I was trying to do full screen, and then when I don't know where the plus and minus went, so I lost it there. Sorry. Here, go ahead.
So dumping out of here, we dump back into our main suction. Now, this rack had bypasses around every filter dryer and the oil separator. It doesn't show it on the oil separator, but they had one there too.
Yeah, so right here, there's your filter dryer going down to your suction there. And then it looks like this is the part of the suction where you're getting all the returns for all your loads, whatever they might have been.
Yes. Then we had, on both suctions, we had stepper valves for liquid injection.
What is this? What is this suction bypass thing?
So that was there for, I believe that is the medium temp to low temp.
Oh, load shedding. Load shedding. Okay. All right. Sorry.
We really didn't have to mess with it much. It was there just to keep it from any issues from happening. But
I guess it's a trainer, right? So if you only have, let's just say 2 or 3 loads, and one goes into a defrost, the unloader can only unload so much, right?
Yeah.
So essentially, it just takes some of the medium temp and throws it in there via the M12 here.
The low temp only had 2 circuits right now. It's designed. Eventually, they're putting in a walk-in in some cases. So it was pretty much open the entire time just to give the low temp some more load. So standard on the low temp, we had just the 410A Copeland scrolls. So in there, we had a digital and like Aldi style, digital and a fixed speed, dumping into the suction of the medium temp.
I don't know what the hell's it doing up here.
Hot gas.
Oh, okay. All right. We didn't get there yet. Sorry.
The add-on circuits are hot gas.
All right. So let's go here first. So you have to go to the destabilization.
Yep. And then there is a Danfoss defrost differential valve
for that hot gas
that is disabled and at medium temp suction pressure when it's not. Like, this would fix a lot of the Carnot issues where you're running pressure, or you're running compressors at 500 pounds when you could be running them at 400 pounds. You drop the pressure 100 pounds by changing this Danfoss valve around. This is great.
So it's just boosting the discharge pressure.
Yep, boost it up to above the flash tank. So I think it's 20 pounds above the flash tank is what they were shooting for.
Only 20?
20. It's a trainer. So like it's, you don't have.
Oh, that's right. You don't have the footage of run.
Yeah, literally the walk-in is 15 feet away from the total piping. Up and down is probably 15 feet away from the rack. So you're not going to have that. So you would have to run it higher on a normal system.
So what do you recommend? I was thinking like 60.
Yeah, 40 maybe, 50.
40? Okay.
Yeah, 40 or 50. 40 is usually enough. And then we have liquid injection going into that medium temp line where it's dumping in. So we had a stepper, not a solenoid. We had a solenoid controlling the inlet to it and then a stepper injecting into it off of a calculation of superheat.
For a failsafe.
For a failsafe.
No, but I'm saying the solenoid's there for a failsafe. So if God forbid it would stop, the rack would just shut down. At least this would de-energize.
Correct.
I'm assuming it was probably like all these solenoids de-energized if there was no compressors running or something like that. Yeah.
If the medium temp pumps shut down, then it de-energized the circuits.
Makes sense.
So it was looking at the proofs. Now, if you go up to our circuits, so on this particular rack, it was all water. So there was 250,000 BTU boilers flowing into heat exchangers. So the unit had piped in two little like combo boilers, and there's a primary secondary water loop. So they were heating heat exchangers on the rack, and then they were supplying water with a pump on the rack to these. So we are taking like 85-degree water and dropping it down to 25 degrees.
So is the boiler, because I didn't even look at this thing fully.
The boiler's not going to be on the P&ID though. Wait. These are the heat exchangers.
Oh, this is the water side circuit of those heat exchangers then.
Yep. And so like they just have the 140 and 120 connections. So on those heat exchangers just go to the boilers.
Gotcha. All right. I'll go back to the circuit. Sorry.
Yeah. So we just had liquid line solenoids on here, and normally you wouldn't have that for the most part, but this is a trainer, and if the compressor shut down, it needs to instantly shut off. And then we have EPRs, and we have liquid stepper valves for the suction superheat.
So these are your EPRs. This would be your expansion valve.
Yep. We had a lot of playing around with this because it was a trainer. If it shut down, it rapidly expanded and kept popping reliefs. But once we got it to calm down and the valves to close a little bit faster on shutdown, I mean, it stopped doing it. So it was pretty cool.
I almost had a heart attack for a second.
What?
Quick second, because I didn't see the little red recording thing on the top.
Oh my God. I would have killed you.
It was behind the mic and I didn't see it. I'm like, I started moving my hand around. I'm like, oh no.
It's not the first time you've done that.
That's right.
Yeah. This thing had temp sensors and transducers everywhere. It's pretty sweet and nicely laid out E3. So it was nice to actually get to play with something where I could test it and, we'll see what this does. Now we're going to talk about the next part of this. There were these videos. So these sight glasses on the drop, they had sight glasses on the drop leg before and after the HPV. They had sight glasses leaving the BGV going into the suction header, which is cool. And they had sight glasses on both suction return headers, so you could see liquid coming back. We had a lot of slugging in the beginning on the low temp, so we got the P&ID or the PIDs kind of tuned in.
Oh, I also see right here that on the hot gas return line.
Yep, there's one there too.
So you can actually see how much liquid is being created and going back into the tank.
Unfortunately, we did not get to test the hot gas yet because they didn't have the evaporators for the boxes.
Oh, gotcha. Okay.
Oh, another time. I'm going to go back there and probably teach a class with this Union Hall. So hopefully they're going to have another box donated by a manufacturer so they could put the coils in.
This thing has a lot of stuff on it. Damn.
Oh, and then a lot of it was talking to the guy, like a lot of this stuff ARNeg is not allowing customers to not buy. Like their bypasses around valves are not optional, like stuff like that. They built a class act rack. Like this thing was nicely laid out. They built their own electrical panel. Like it was made, everything was made in house. It was nicely laid out. The wiring diagram was like simply written how a technician could fix this. Like ball valves were all accessible. They weren't buried. They were turned to the sides on the ones that were like anywhere there was armor, anything on top of them. They turned the ball valves to the sides so you could access them. There was space in between the circuits to pipe things. Like every single TIG weld was like almost rainbow colored. Like they did it like it looked beautiful. Like the TIG welds looked like they were Instagram TIG welds. Like I'm serious. Whoever did these, like you could tell took pride in making welds. Like they did a really good job on laying this thing out and going through and doing stuff.
So here's the control cabinet.
Yeah, this is in the midst of me rewiring some of this still because we converted. So they have these fixed stepper valve controllers in here for the Emerson CX valves, and those the only ones that are left are the ones that control the actual EPRs and the liquid injection. We ended up switching out the rest of the evaporators for superheat controllers so we could actually change the superheat and give them a little bit more control and then show them on the actual E2 or the E3, okay, this is what the valve driver is doing. There's a little bit more information on it and it's a little more intuitive. So they actually changed that on the fly as we went down there and went through this and we rewired it and we did it with the Union Hall kids helping the apprentices. Well, it was a cool experience for them. And like for me, like it was nice. We learned a little bit about it because I didn't know on those SH1 controllers, when you go to do superheat on CO2, you have to do 4 to 20 milliamp transducers. Even though they have a 0 to 650 in there for a ratiometric, you can't use a ratiometric transducer on CO2. You have to use a 4 to 20 milliamp.
Interesting.
So what kind of like hosed us is we didn't have the connectors for them for the transducers. I happen to have 5 M12 connectors on my van for Sporlan CDS valves. So I had to sit there and move the connector around one by quarter turn until I figured out which wires ohmed out the right way.
Oh, shit.
Then I got them all done, and one of the apprentices was like super anal apparently, and we pulled the wires all in, and he moved all the connectors so they were facing the same direction, except none of them were supposed to be facing the same direction because they were all pinned out for red and black. And then I had to sit there and do it all over again.
Man, I know you sent me a picture of this rack and I can't find it. I'm looking through all the chats. The kids, the other one.
I'll send it again right now. Yeah, it was a super nice rack. Like I
gotta be careful with that chat. I can't bring it up. I'm just saying, either of them, I can't. Like that's how you get canceled. It's cancel culture right there.
Just us making fun of Dylan. All right, let's bring up the videos and discuss this.
I don't know. Let me be careful with this. Please not bad. Please not bad. All right. So what's this one right here? This isn't a video. This is just a picture you sent me.
Yeah. So that I think that one's the flash gas.
Okay. Really?
I think so. That one. That looks like the front of the rack.
Look at that. Look at that flow. That's from the flash tank. That's a lot of liquid being fucking moved around then.
I think that one's going in after the BGV. Oh, I'm sorry, after the HPV. That's
okay.
Okay,
I was gonna say. All right, and then this one right here. This is before.
Yes, that's before. So as you can see, like I have a fluke temp thermometer on here. So it's 95 degrees. We're sitting there watching 96 degrees. Look how clear that glass is. 97 degrees. And while this is happening, we're all like 1250, 1350 I think at the time this one was limited to 1350 psi was the max GC gas cooler pressure. Look how clear that inlet sight glass is.
Supercritical fluid it is supposed to be clear. It looks almost like a little bit like a lava lamp.
That looks like liquid to me.
Okay. Technically where it's at, it shouldn't be.
Correct. And there's the other video, you can see where it's flashing a bit.
Yeah, let me go to the next one. There we go. Oh yeah, there it is. There's the flashy. All right, Federico Fellini, stop moving around.
Yeah, this is. Yeah, like the videos are not like the best because there's all these people around me. So that's it. That's it after the valve going on the outlet of the HPV.
Okay, so that's where this is when it should be the supercritical fluid, and then later in the video, over yonder, this is when it's after it's flashing off, right?
Correct. Yep.
Okay.
There was quite a bit of liquid in the thing. It was 70 to 80% most of the time. You're looking at it like where it was flowing. Like there was way more liquid in there than I expected.
Oh, shit. That would have been bad. That's why I said I'm not going through the messages live. Wait a minute. I just download the picture so I don't get myself in trouble. Stop. Downloads. Yeah. Let's move this one over. And then bango. There you go. Start explaining away, sir. Oh, so that's the auxiliary condensing unit.
Yep.
That's that heat exchanger with the bypass with the motorized ball valve there and there.
Yep.
The gas cooler.
It's outside.
Oh, okay. I didn't know if it was inside.
No, this isn't your trainer like your old trainer like it. This thing was literally a giant 2-fan gas cooler outside. It flows out. Those stainless lines you at the top of the picture are going to the gas cooler and back, and then you have relief lines going to and back. So your high side's all stainless coming back till it hits those are the evaporators.
So your 3 medium temp and then your 2 low temp.
Yep. And then you got your 2 stubs next to them. They go up. Those 2 insulated stubs are for the walk-ins whenever they get installed. And then, you got the giant oil separator or the baby oil separator and the giant oil tank.
The oil tank?
Yeah.
Jesus.
Huge. Yeah. Oh, yeah. She holds some oil.
Hey, what are these? What is that? That's not rated. What is that? That's those Vibrasorb clamps.
Stop it. No, those are reliefs. So that's their way of enclosing the reliefs because from Copeland, they just come out of the front.
Yeah.
If they go off in a room, like certain municipalities in Canada don't allow that. So they got to be encapsulated.
So then all your reliefs then go out together, probably through this header up and out. Yeah.
Just those 2 reliefs.
Because they're right in front of your face.
Yep. Every other relief's piped on the outside of the building, which I'm not a big fan of. I'd rather them be at the rack. Because when we popped them, they took forever to get a ladder out there and get them shut off. Medium temp compressor on the drive, super standard setup. So the only thing that was a pain in this thing is that emergency switch on the side of the panel. I had to set that up so it has to kill the boilers and at the same time shut the rack down, but in a safe manner. Meaning, like, I had to kill the evaporators and then put a 3-minute time delay on the iPro kill so that the thing would pump down and shut off. Then I killed the compressors. Because if I just killed it, it would just start popping reliefs.
All right. So there's that. Wow. It's just a lot of piping on this rack. And everything on here is all XHP here?
Yeah, most of that was XHP. Most of it was stainless.
Gotcha. All right. Anything else you want to talk about with this bad boy?
No, let's discuss this. Let's discuss this liquid on the drop leg.
Oh yeah. But the sight glass you were showing was the one before, though.
Yeah, it was before.
That's what kind of throws it off, though. We can, but
it was before the valve.
Yeah, I know. I know.
And then
I know.
after the valve too, I was showing it too. Like there was a lot of liquid after the valve still.
Okay, so let's guesstimate this in pressure, right? So you said you were running about 1400, yes?
Yeah, it's about around 1400.
Okay, so we're at 1400. And then you said your drop leg temperature sensor was about 96, yeah?
Yep.
So even at that, this isn't obviously totally exact, but there's your 10, 20, 30, 40, about 50. So you're about 45% vapor and about 55% liquid, right? That's what it's showing here. It was probably hard to see because I've never seen supercritical fluid in a flow state. You know what I mean? I've never seen a sight glass before it. You only see it usually on any other trainer that I've seen. It's usually always after. So unless when this typically if it's stagnant, if the supercritical fluid is stagnant, it looks like a freaking lava lamp, right?
Yeah.
It has that weird groovy type mix to it, but maybe it doesn't look like that when it's flowing.
It was like crystal clear.
No, I know, but you're also Federico Fellini with your camera. I would really like to go up there and see it.
Yeah, I'm gonna go there again so I get more videos, but it was crystal clear. To me, it looked like liquid. And then like you could see the level. There was the times we didn't get the video. Like at times it's running like 97 degrees. Like you could see the level. It was like 80% level and it had a little bit of flow. So it's going towards the HPV. It had flow. Like it was 80% liquid and you could see the vapor at the top.
Before.
See,
that's what I mean. So I don't know if the flowage like slowed down a little bit, and then that's where you have that mixture, basically that lava lamp.
But it was like that for like 20 minutes.
Because you don't really do anything like up here. This is where you were before, right? Because your HP is essentially going to be right at this drop, right? That's what's dropping your freaking pressure down. So anything above where you were at, if you're running, whether you be running 1400 or whatever, even if you're running, you said at times you're running about 1200 or something, right?
Yep.
Even running 1200, if we move this line over a because you're running about 95, 96, right?
Yep.
Your quality really hasn't changed that much. Look, 10. Ah, shit.
Now you fucked it all.
Dude, I got my fingers around the Control Z. I got it ready. 10, 20, 30, about 40. Yeah. So 70, 30 mix. But like I said, you're still at that super critically fluid above there, right? This like
allegedly.
Oh my God. Maybe your pressure transducer wasn't calibrated because you had to use the 420.
Not on that one. And there's two of them there. There's
I'm
two
joking.
of them there.
I'm joking.
Allegedly. This is all theory compared to what, according to who you talk to.
Yeah, I wonder. And this was before, because so we were talking about what would happen if you'd cool that line down, right? So when you put that heat exchanger in play, because
it was
basically
pure clear sight glass flashed again.
That's what I'm saying. So how cold did that liquidy part get?
Depending on how much we flooded the heat exchangers. So when I raised this lower to superheat from 25 on the heat exchangers, because we had to keep it pretty high because it's so close. So when I lowered it from 25 to 15, I dropped the drop leg temp like
to what?
12, 13 degrees when it was running like 90. So it was running like, yes. Because we were flooding out the heat exchangers basically.
That's going to bring you all the way over to shit. It's going to be like really outside the dome. So I mean,
now we're in a Walgreens situation again.
Yes,
we're running like 1,350 pounds and 55 degrees.
Yeah, wow. Your evaporators were probably really freaking efficient at that point. 12 degrees. That's fucking cold.
How? Not 12 degrees. Like it dropped at 12 degrees, meaning not 12 degrees.
I was like, man, oh shit.
Like, so is it more efficient than the Walgreens one?
80. So if it was at 90, 96 before, right?
Yeah.
So 12 degrees lower than that.
Yeah.
So 84.
Yep.
So even at 84, yeah, even at 80, this is all guesstimation here, not exact. Because the Bitzer app didn't like what I was doing. I'd have to use the other one, and I'm not as good as that one. But let's see, 10, 20, about 25. 25% leaky, reverse that. 75% liquid and 25% vapor. what you're running. I would like better videos to see if you could see because like I said, I've seen some supercritical fluid, right? But I've never seen it in a flow state. You know what I mean? I've never seen it through a cyclist.
It wasn't doing the lava lamp thing. It wasn't doing any of that. Like I've seen the supercritical fluid. It wasn't doing any of that at all.
It bothered me.
That's what I was looking at, and like the Jonathan, the engineer, was with me. He was the first one they've put a cyclist in a drop leg. He goes, there is a lot more liquid in there than he expected.
Versus what the enthalpy is saying.
Yeah,
I mean,
versus what the enthalpy chart is saying, there was a lot more liquid in there, and so obviously, like I'm forcing it into this state, so it's a little. I'd be interested to see on a hot day what it runs, but like I had the condenser capacity cut down because I had the split valve down. That way we could. I was running like in 50%, so I was able to keep the fans still had air moving across it, but we weren't getting a ton of subcooling.
That's why Kaiser uses their parallel compressor to do the. I think they use a flash tank, but I think they also have to do the subcooler as well, because then they'll actually put a subcooler right. Yeah, you know what I mean. So if you're getting 80 degrees, fine, but then they get it all the way down to about 60 degrees.
I think the drop leg subcoolers work awesome for medium temp reheat, but the problem is, yeah, sure, those work great when it's warm out, but they suck ass when it's cold out.
You don't use it then.
Yeah, but what am I using for my medium temp reheat at that point?
Lame.
We need the medium temp reheat just as much in the wintertime as we do the summer. More so, sometimes more. So that's where you got to design this with. I think a rack almost needs two forms of reheat. If you're going to do that, I think it needs some discharge reheat too.
Yeah, because your flashy tank would be right about which means flashy tank. Yeah, that's the technical name. Yeah, so that means what? 10% fucking vapor and 90% leaky.
Yeah,
that's if you have one of the braze plates in there, right?
Yeah. I thought it was super neat seeing that cyclast in there, and I was surprised. I think that people are underrating how much liquid these things are actually still making when they're transcritical. I think they're underrating it.
What was the flash tank set for, man?
510.
All right, so that's going to move that even a little bit worse then, because I had that one set too high. I should have asked you that.
It was like 500 to 510. We were playing around with it, but like during those videos, it was at 510.
So even if you were doing 1400 and getting up to about 95 or whatever, right? Probably about, So if that's the case, then 10, 20, 30, 35-ish vapor and 65% liquid. But like I said, I honestly know, I know you're not as old as me, so your eyes are better, but it just doesn't make any fucking sense, man. Even the engineer said that he was taken aback at the fact that it didn't look like that supercritically type fluid.
Yeah, because everybody's looking at it like me and James and Dylan, as we were making fun of Dylan, we're talking about this. As we're talking about this, yeah, everybody wants to bring up the test chamber. The test chamber is not dynamic, and I don't know how many times I'll die on this hill. A test chamber is not a dynamic system. Like in a dynamic system, there's much more going on. So like a test chamber shows one thing, but like when you have flow and other things happening at the same time, like that test chamber is useless.
This would have been an awesome conversation to have with Bob.
Yeah, I think we should have a conversation with Bob and bring it up. But do you agree? Like a test chamber is one thing, but when you have an actual operating system, flow, the flow, I think changes it.
I don't know. I'm not an engineer.
Shut up.
I'm not a fucking mechanical engineer. Not a fluid dynamic engineer.
Just because it doesn't say P next to your name yet.
Not yet. Apparently, there's some states where they give you like participation P's. They're like, "Hey, you want to apply?" Sure.
Now you're going to get in trouble.
It's like Texas when I got here. They're like, "Oh, you do refrigeration? Here's your participation card."
Surprised the state of Texas hasn't given you a participation PE yet. You're our smartest person.
Such a dick thing to say. Jesus Christ. Before you actually get us canceled, is there anything else you want to talk about?
No, that's about it. That was my week.
Yeah. Man, I don't know, man. It's just, you know what it is? It's straight up voodoo. It doesn't make any sense. It's voodoo. Why the flow looks the way it does? You know
nobody
what I mean?
could say what it actually is because it's supercritical fluid. Is it more liquid? Maybe it is. Is it more vapor? Maybe it is. But until you actually look at it, like, sure looks like liquid to me. And I also tell you, like, I flooded the living shit out of I didn't have a video of it, but like, I dumped the HPV into the flash tank and caused the load to go real high and the flash gas bypass to open to 100. You could see the liquid, quite a bit of liquid coming out of the flash tank bypass valve on the sight glass.
You need to take some videos when you go back to that.
Yeah.
Because we talked about it, right? And we talked about the theory on what happens when you have that shit higher than that, yeah?
Yeah, like the original iPro issue when they had that issue with the switchover. But they fixed it. It's where it was like locking at like 950 and it was overpressurizing the flash tanks and it was causing the flash gas bypass. It would only do it like after a weird transition period. It was very few racks that it affected, but like it would, when it went to go transition, it would lock that flash gas bypass valve. And then anybody with a lay down receiver was just sucking liquid out like a tornado.
Not a good thing. Well, because I mean, you saw your picture when we had the P&ID out there, like how the internals, and that's what I wish more prints would show, right?
Yes, the internals.
Yeah, because like you're like we're looking at something where I was like, "There's no dip tube," and you're like, "Whoa, maybe there is, maybe there's not," because it doesn't show it on the P&ID. That doesn't mean you'd have to get the manufacturer to be like, "Hey," but the thing is, like, a lot
Good
of
luck asking them because sometimes they're like, maybe. What does maybe mean?
And that's it, because everyone has their special thing, right? Because a vessel is a vessel, right? It's what they do with their piping on the internals, which makes them special than everyone else. But if they don't want to release their secret sauce, so to speak, they're like, yeah, we're not going to show you. That's only for the manufacturer. You know what I mean? That's only for the customer. You know what I mean?
Yeah, I will say this. We had the newer version of the iPro over here, like the latest version. Barely any tweaks to this thing. I tweaked the PID a little bit. It just took right off.
Really?
Like flash tank within 3 to 5 pounds. Like I barely tweaked the PID just a tiny bit. Kind of some of my HPV valve settings we do just took right off.
Sweet.
Like barely had to tune anything. They got that thing pretty dialed in on the FO4 version. Is
it like the whole controller is gray now? Kind of like
it's the one that has the Copeland markings on it.
Okay, but I'm saying it's like it looks like the CC200 type thing.
The XEV valve D driver does. The iPro was
still white
with Copeland letter. It doesn't say iPro Genius anymore. It says Copeland.
Okay,
but it's the latest one. Like I tweaked the P and the I just a little bit in some settings here and there. Like it just took right off.
Why did they put newer base settings in it, or what?
They tweaked a bunch of stuff in the back software. It's like when it switches over, I know that they took it and they made it so like when it goes to subcritical, transcritical, when it switches PID sets, because it's two different PID sets, it locks the HPV valve for a few seconds, so the other PID could take over.
Yeah,
and it just, I don't know. It seemed like it. I spent way less time tuning it than I ever do.
Cool.
And this is the second rack I've used it on, so like it's been this. I pop this just close to the same settings in there, it just takes right off.
Gotcha. What do you got planned for next week? Where are you going?
I am starting up a booster rack at another site. So back in Chicago, the largest laid out rack I've seen so far with the most room. Like you could do like backflips on this thing.
Really?
Yeah, there's like the whole back side of it is all completely open. You could build a cot up there.
I'll have to show you some of the ones from Cape Town.
It's 30 foot long.
Wait till I show you the picture of the other one. It's freaking huge.
This thing, I will say though, has the biggest flash tank I've ever seen in it. It's over 9 feet.
Tall?
Yes.
It's kind of crazy.
It is massive. Like it is gonna take so much gas.
We're going to Colorado.
Oh, are you? Ew.
Yep.
It's getting warm out now, so
I like Colorado.
you get attacked by one of those wolves that are just killing everybody's cows.
What?
Yeah, there's like all over the place.
Maybe I'm not going to Colorado.
The whole state's is overrun by wolves now because they'll release the wolves everywhere.
You're such a dick, man. I hate you. On that note, we're going to go. Have a great weekend. Talk to you guys later.